Hi, how you going, everyone? I wasn't expecting an applause, but I'll take one anyway. Before we get started, I'm just curious, how many demos have we seen so far today? And hang on, actually, let me explain what I mean by demo. Not here's a UI and I've clicked, actual demo. Today we're going to get a demo on a Kubernetes cluster, and we're going to look at what AppSec looks like from code, from a developer, all the way to an app that runs on Kubernetes and then can potentially be redeployed from one version to another, right? So it's an important concept for us at Snyk. So my name is Pas, I'm a Principal Solution Engineer here at Snyk. So we're probably going to do about 10 minutes of slide and probably about 20 minutes of demo itself, and I've got a nice little countdown clock here as well. So before I get started, I do work at Snyk. I've been at Snyk for a year and a half now. Before that, I worked at companies such as VMware, Pivotal, Elastic, and then also, unfortunately, at Oracle. There's Oracle here? Oh, hang on, DevOps. That's silly, Oracle. All right, cool. So I just want to kind of set the scene for AppSec, or at least AppSec for how it should be considered, right? And so the very first part of AppSec from a developer-centric point of view is most developers are using open source libraries, right? So it's just one way to innovate, to reuse what's already out in the community and get your app out to market faster, right? So it's a pretty important concept. And if they're using open source libraries and they're in the community, that presents a risk, right? So malicious code can get into these open source libraries and vulnerabilities can surface over time as well, right? So 90% of organizations use open source, so it's big. And then there's containers. So we're writing this code, we're using open source libraries, but we kind of need to deploy it somewhere. And there's still some organizations that deploy things on VMs, but more often than not, they're making their way into containers, right? So if you look at what this slide's saying now, like containers will be in use by organizations, 75% of organizations will use containers as of this year, right? So it's already well on the way, right? So you need to now think about vulnerabilities in those base images for those containers, but ultimately what runs in those containers are application artifacts. So you're going to see from Snyk what it means to actually go and scan a container end-to-end, not just the base image for the Linux vulnerabilities, but also the open source artifacts in that container. Because day one, when they're deployed, they may have no vulnerabilities. Day two, we've got a log4j, 0-day vulnerability. What would the business do if they don't know which containers have this log4j issue? Infrastructure as code. Clearly, if you are going to be deploying to the cloud, you're going to use infrastructure as code. Unfortunately, the default for infrastructure as code is not always the most secure way, right? And so we call them misconfiguration. So that ability to be able to check your infrastructure as code template files, not specifically what's happening in the cloud, but before you've deployed it, is king for the developers. Really important concept. Last but not least, in terms of a developer and what he needs to focus on, his actual IP, his actual code. So whether that's an API or it's a web app, he's writing code to perform the business logic. And as you can imagine, security issues can result as actually part of that coding effort. So SQL injections, cross-site scripting, and there's others, right? So all of these, ironically, live in what's called the repositories, right? So whether they're public or private, they're going to have ISC files, they're going to have the code files, they're going to have the Docker file that's built the container, they're going to have the open source manifest file. And last but not least, what does the cloud security posture look like when an application is running, right? So do we have drift? Has something changed from what the developer or the DevOps organizations within, DevOps teams within an organization, are they still seeing what they should be seeing when they're running in the cloud? And then you want policy management, you know, who's going into the containers, for example, the VMs, all that sort of stuff is cloud posture management, right? Which is something that Snyk is evolving to, not quite at yet. So this is my favorite slide for one reason, it's visual, right? So instead of all these bullet points, right? But what I'm going to show in today's demo is what it looks like source to run from an application security perspective, right? So developer's writing code, he's checking it into his repository. Snyk is scanning that repository constantly, not just a one-time scan, but constantly scanning it. Then when it's eventually made its way to a container registry, Snyk again is scanning it as it hits the container registry as well. And then we want to see over time what's happening in our Kubernetes cluster, because if you can imagine, a container registry is just a dumb blob store. It's just a database. Sits there with all these registries, containers sitting in this registry. But what you really want is which applications are running in Kubernetes while they're in production. And I want those to be automatically monitored all the time, right? So we're going to see that in the demo today, how we pick up containers that run in the Kubernetes cluster and automatically bring them into a centralized UI so you can see what that looks like. In this slide, I am bringing up Snyk as well because they're, in my eyes, kings in terms of runtime for containers. Snyk is more AppSec, more the developer focused, but we do have a Kubernetes monitor, which we're going to see in the demo today, which actually scans containers as they hit the Kubernetes cluster and run for the first time. So all of this is how you would look at it from getting an app from source all the way into Kubernetes. Now, you might be wondering, is Pat's going to show us something from a DevOps pipeline perspective? But no, what I'm going to do today is look at how all these different integration points in the software development lifecycle are points of interest to the business and the developers to be able to fix these things while the app's running or prior to when the app actually runs. Because anyone can, in a pipeline, run a test and fail a pipeline, but that's not really valuable. What's more valuable is integrating into the right points, integrating into the container registry, integrating into SCM, integrating into the pipeline, of course, and then integrating into the Kubernetes directly itself. So I'm just going to show some, this is what I call level 1 demo screenshots, because you're going to see this in the demo itself. So you can see here, why am I looking over there when it's right in front of me? So here what I'm looking at is a developer being able to run a Snyk scan across open source, across SAST, across ISC, and across container, all within IntelliJ, for example. And to the right, we've integrated with GitHub, and we're constantly scanning every single file that's in our GitHub repo that comprises of what this application looks like when it's in runtime. So from the Docker file to the code, to any Kubernetes YAML or JSON file, and depending on how you deploy into K8s, and then the open source manifest file. So we're actually going to demo a Spring Boot application. So that's what we're going to see in today's demo. And then what we're going to do is look at the application when it's been deployed to the registry. So we're going to do a scan in Docker Hub as well. And then we're going to look at it when it's scanned in Kubernetes as well. And I'm going to show you how when an application is deployed on Kubernetes, I'm going to use Argo CD. I'm going to drop CI. Right, we're just going to go straight to CD here, just in interest of time for the demo. But I'm going to show you how you can run some scans in Argo CD. To be honest, from a Snyk perspective, it's so simple to install the CLI that it doesn't matter what tool you're using, you can run a scan at any of them, right? So in Argo CD, I'm going to drop down to the CLI and I'm going to run an IAC and container test. I'm going to let it pass so the app deploys to Kubernetes, and then we'll see it automatically injected into the cluster. This is my favorite slide. I worked really hard on making this look as good as I could, right? So we've got 22 minutes. I'm going to go into a live demo time now. So, all right, cool. So what we're going to do now is we're going to look at this Spring Boot application, right? So I chose Spring Boot because I'm the worst developer, and if you've ever used Spring Boot, you'll know that it will help you, right? So that's why we've built a Spring Boot app. Now, if someone's shaking their head, sorry to hear that, but should, right? That's the key, right? So what we're going to do now is we've got this app here, and it's in GitHub here. So Spring Boot Web is the app name. It's a very simple app, just an API, a couple of REST endpoints. There's some Kubernetes YAML files in there. There's also some Argo CD YAML files that we're going to use for the deployment as well. So what I'm going to do first is I'm going to show you within Snyk here, this is what we call Snyk app or Snyk UI. We've actually imported that Snyk Boot web app directly from GitHub itself, right? So if I was to just expand that, you can see that we've run a SAS scan on the actual code, right? We've got some scans across the YAML, which is what we're going to use for Argo CD. We've actually scanned the Docker file, and we've also scanned the pom.xml, which is the open source manifest file for the Spring Boot app, because it's a Maven app. And we've also got a Terraform app, right? So I can even deploy this in Terraform as well. So you can see what we're doing at Snyk here is we're giving you the ability from the business perspective or the AppSec perspective or even the developers to see across your repo all the different vulnerabilities and all the different touch points here. So that is what I call integration 1. Integration 2, I'm going to switch to this little thing called IntelliJ here. And what I'm going to do here is, not this one here, so I'm just going to kill that. This is that same web app here in IntelliJ. What I'm going to do is hit this little Snyk endpoint here. And you can see here, just by hitting this little plus symbol here, it's going to do an open source scan, it's going to do a code scan, it's going to do an ISC scan, it's going to do a container scan for me. So I'm already getting visibility across what issues I have before I've even deployed the app, right? So notice how I'm talking about integration points before we've even hit a pipeline here. So one was integrating with SCM, so as things happen, commits, pull requests, successful merges, we're constantly scanning. Here now I'm the developer and I can just run that, hit that little plus symbol and go and find out what vulnerabilities exist. So if we just did this open source scan here, for example, this one here has the world famous Log4j issue that came out, I don't know, maybe 6 months ago now. And it is in our POM as a result of using the wrong version of Log4j that makes this vulnerable, and it's sitting in our application at the moment, right? So that's even before I built the container as well. So it's done IAC scans as well. The key thing with IAC when we're talking about Kubernetes is how are we deploying the app, right? Are we running the default route? Are we setting memory or CPU limits? Have we decided to drop Linux capabilities? Do I really even need them? All these sort of things that you can accidentally do by default. So what I'm going to do now is I'm just going to switch to this thing called a terminal window here. So if I was to run an SCA scan, 18 minutes, all good. So I'm going to do this here. So now I'm switching to a CLI. So think of this, I'm in a DevOps pipeline. I can run this scan of the open source before I even have to go and create a container out of it. So I already get a viewpoint of exactly what's happening just by running the CLI and getting all the vulnerabilities from what's in my pond. This has been derived from what's inside here, right? So the pond.xml, probably best to just show it in here. It's been derived from what I've defined in here in terms of all my different Spring Boot dependency libraries that I've used here, right? So the other thing that I can do quite easily as well is the next thing I'm going to do is run a container scan. So this app has already been built and deployed to Docker Hub itself. So what I'm going to do now is on the integrations tab, switch to just Docker Hub, and there is my Spring Boot web app version. The tag is v1, and you can see here it's done two types of scan. It scanned the base image of the container, so it's using the tag name v1, and it's also found some open source jar files, which is what Maven does when it goes and deploys the application. All those get included in it on the file system, and done a Snyk open source scan of that as well. So just on this Docker Hub container, if I go into here, I can already see that I can see my log4j issue in here, right? This is me scanning the container, not the code, not the pom.xml. It's direct. Snyk has directly gone in here and found the log4j issue already in this v1 container that's going to eventually get deployed to Kubernetes. At the same time, I can go back here and I can do a container scan. This is where it gets interesting, right? So it's all good and well that I can scan and these are all my vulnerabilities. Help me fix them. That's the key here, right? So if I went to now just run a scan of that container image, so just two here. So it's going to give me all the vulnerabilities, which I can see from here as well, right? So if I went back to projects here, if I choose this base image, one of the cool things here, a container sitting in a registry is based on, it's an OCI container, right? So it's a binary file. But Snyk needs to go and inspect that, work out what the base image is, tell you how many vulnerabilities are in the base image, and then recommend what alternative upgrades I can use to remove as many vulnerabilities as possible. Now I'm using JDK 11. The world's kind of moved on from that, right? So I was using 8 for a long time, but anyway, if further I go down the stack, I just don't want to use anything that has the word Oracle in it. So at that point when I got to that, I stopped, right? But ultimately, if I can choose a better base image that has less vulnerabilities, that's going to mean my application is safer, specifically if I can reduce the amount of criticals. And that's easily done just by changing the from tag inside a Docker file, which we can do inside the integration that we've done with GitHub, or we can just highlight it here in terms of the container itself, right? So if I was to go back to here, do projects, 15 minutes, so all good. Switch back and let's turn GitHub on at the same time. So it can tell me this same thing just from the Docker file scan. What's really cool about that is I said that it's telling me what base images that I can use. I can just go and say, well, you know what, let's at least go to this 11.16 one. We can at least remove 3 critical vulnerabilities. And so I can just go and open up a fixed pull request and go and get Snyk to create me that, change the Docker file, and then if the developer's comfortable with that version of the base image, he can run test his app, I can go and merge that pull request and bang. We're a little more secure than what we were a few seconds ago, right? So, but what I am going to do now is let's just switch to here for a second. The other thing we can do is also run an IAC scan, right? So if I look at that, so I'm kind of just touching all the integration points as well as the capabilities within Snyk here. So the app that gets deployed is deployed through this Snyk boot app-v1 YAML file. So if I was just to cat that. So it's really simple, basic deployment file. It doesn't specify anything, so we know we're in trouble already and we haven't even deployed it. And it's just got the image that we're going to use, which is the V1 of that. So what I'm going to do though, is I'm going to switch to a terminal window on this side here. Let's just make sure that we're connected to Argo CD. So let's go here, let's hit refresh. Does that maybe need to be maybe just a bit smaller? So I already got a couple of apps running in here in this Kubernetes cluster, a guest book and a Spring Boot employee app. So what I'm going to do now is I'm just going to deploy another app here. And the deploy will look something like this, right? So we're going to call this Argo CD command line utility. Then we're going to tell it point to our GitHub repo. It will then find the files sitting in the Argo CD deployment directory and go and deploy the app, right? But something unique happens when we do this as well. So I'm going to hit 6 here and deploy. So while I'm doing this, I want to run some Snyk tests as well. So what I'm going to do is, this takes not too long, but a little bit of time. So what I'm going to do is, we should see Argo CD waking up. You see it's in an orange state at the moment. So I can click on, oops, not that one there. Let's click the right app first. You can see here that it's running. It's not quite at the point that it's finished, but there's actually, as part of this, I'm going to run a job. So what I'm going to do is show you inside here itself. So if I go to Argo CD here, and we look at this Snyk IAC scan, you can see here that I'm initiating a job as part of this Argo CD deployment. I'm cloning the Snyk Boot web app. I'm authenticating with Snyk. I'm running an IAC scan, and I'm running a container test scan. And we already did that on the file system, but I'm doing it again in the pipeline. Now, by piping it to true, I'm telling it that I don't want you to fail this, because any status code that's not successful is automatically going to break in any CI/CD tooling. So what I've done here is just go and report on it for me, but don't go and break the actual deployment itself. So if I go to this little job here, and I go to the logs, you can see here, again, this is not great from a sizing perspective. You can see here that it's ran an IAC scan that's talking about the containers running without memory limits. There's no liveness probe. There's no, it's running with a writable root file system. We're running as root, all these different sort of things that we don't want to be doing when the app's deployed. So what I'm going to do now is, because we're running this something called a Snyk monitor, so I'm going to show you what that looks like. So the Snyk monitor is just a Helm chart that runs in the Kubernetes cluster. Just one single pod sitting there waiting for workloads to be deployed on the cluster or deleted, and automatically kicking in and doing something from a Snyk perspective. So if I was to run that, nothing overly exciting here. We'll see that we've got this Snyk monitor. It's just a single instance. You can run multiple instances of it, but this is just one, and it's backed by a deployment. And I've obviously restarted it a few times. That's what all these replica sets are. So that running itself, if I go back into my Snyk UI here, and I now say that I only want to look at just Kubernetes workloads. So I've gone and integrated with Kubernetes. That's why this appears. Maybe I can just make this a little smaller. Hopefully that's still all right. But this is the app, the Spring Boot Web Argo CD. It wasn't there before, and I can tell you it wasn't there by just clicking on here, and you can see that this was tested 2 minutes ago, meaning that as part of what I just deployed, it was automatically imported into Snyk app. Now what you see here is a couple of things. One, the log4j issue is already there. If I go to the base image itself, we'll see that we're still using that same base image that the container that was sitting in Docker Hub and the Docker file we're using. So we haven't fixed any of these at the moment. But the really cool thing here is that Argo CD, when I ran the test, I could have broken the build by saying you didn't set these specific values on the deployment. But even if someone inadvertently didn't do that, we can just click on the top level component here, and we will automatically run these secure configuration tests. So the only one that passed here is privilege. I've set no CPU limits, no memory limits. I'm still running as root. The file system is not read-only, and I'm not dropping any Linux capabilities, right? So to be honest, most stateless apps don't need the Linux capabilities, but they're there by default. Should someone get into the container, that's your problem, right? So until then, you might feel like you're okay, but that's pretty dangerous, right? To leave all the Linux capabilities, or at least drop all and then add the ones that you know the running container may need or may not need, for example. So what we're going to do is we're going to fix these, right? So I don't really like that there's so many of these failures. So what we're going to do first, though, is I also want to if I go back to projects here, I want to fix two things here. So while we're here, I'm going to change to a different base image, and let's use just this one here. The reason I'm just using this one here is A, I'm not a big fan of Oracle, but also it's still JDK 11, which means that the chance of the app running is more successful than not, right? If I'm going to switch to one of these open JDK 19 images, I need to then pay close attention to the Docker file. And, you know, am I trying to add users and groups, and how's it different when the image has changed over time, right? So we'll just pick this one. So I'm going to go here. How are we going for time? 8 minutes. It's gone red. Okay, hurry up, Pass. So what I'm going to do is I'm going to rebuild this container, and I'm just going to pass a v2 tag. But what I do want to show you quickly is the Docker file is already using this image, already ready to use this image, right? So I'm building it off that. I'm leaving everything else, right? So taking the jar file, whacking it into the container. That's another reason I'm using Spring Boot is I don't need to compile anything. Just grab the jar, put it in there, right? So I'm going to rebuild the container. This is going to be the v2 version of the container. Shouldn't take too long because I've run it about 45 times. So yep, so it only took about 12 seconds. So now I've got a v2 version of the container. I can do a couple of things. One thing we will do here is let's just see if we're indeed using that new base image. So I can go to projects here. I can switch to just Docker Hub. So I'm going to say add to project. By the way, what I'm showing you is all done through the UI, except for when we did the Argo CD deployment, which was then automated by the Kubernetes monitor. But if there's an API, CLI, all this stuff can be automated and automatically added to the UI without me clicking around, right? I'm going to go to Docker Hub here. I'm going to look for Snyk, boot web. Hopefully there's two of them now. So there's the v2. We're going to import that, right? So that shouldn't take too long to import, but remember, it's got to do a scan of the base image and it's got to do a scan of open source, right? But all I want to see is, am I using that new base image that I said I'm going to use, and what are the alternative upgrades that are still available for me? So what we are going to do, though, is rather than using Argo CD, let's go and deploy a new version of this app and fix all those ISE problems and show us how Snyk is importing it and showing us whether or not the ISE fixes have indeed taken place, right? So back over to here. So what I've got is I've built this little, which I know is going to work. Well, it's even called fixes. So I'm adding the most crucial component is the security context, right? You know, you leave that out and you're going to end up with heaps of ISE misconfigurations, right? So I'm running as root, as non-root, I'm setting to true. I'm picking a user that is going to make sure that it's not using root. I'm changing the read-only root file system to true. I've dropped all Linux capabilities, and I'm setting some resource limits and CPU limits, right? So again, not a security issue, resource and CPU limits, but a starvation issue can present a security issue as well to the cluster. So what I'm going to do is just actually deploy this using kubectl. So I'm just going to say cat7, which is just this. I'm 5 minutes and 45 seconds. So this time now I'm deploying a new app. So if I do kubectl get pods dash namespace pairs, that's the name of the namespace. It's probably already running, right? So the other one was called Argo. This one's not, right? So, and if I was to actually go and get the logs of the monitor pod, you can see that it's just constantly doing stuff all the time. Every time new things hit the cluster, it's scanning, right? So it may take a few minutes, but eventually it will get added to the cluster. So I'm just going to leave that. And also, as applications are deleted, they're automatically removed. So you can already see here that it's doing work here in the background. You can see that Snyk Boot Web App was one of the ones that it just did a scan on now, right? So what I do is let's have a look whether or not that import actually works. Let's do a refresh there. So I've got a V1 and a V2, already seen V1, so V2 down here. Did it change that base image? And hopefully it did. So we are using the 11.16 Slim Buster. Sure, it only fixed a couple of vulnerabilities, but hopefully you get the gist of what I'm doing here in terms of the demo. And now maybe it's time to go to one of these open JDK images and really remove the number of vulnerabilities. But if you move to those more later images like OpenJDK 20, there's less vulnerabilities than there are in the older images themselves, right? So hopefully by the time now we go back to, I've got 4 minutes here. If I go back to projects here, and the Kubernetes monitor was kind to us. What do we got here? So there's the Argo CD one, as you can see here. Nothing's happened on that 8 minutes ago because it's a separate app. I've done a new deployment. But if you looked closely, you would see that there also is this one here. It has no Argo CD. That was automatically imported a minute ago, right? So I've gone pretty quick here. I should have fixed the log4j issue, which I could have done with a pull request. You saw me create a pull request on the back of changing the Docker file from tag. But as you can see here, I'm showing everything but a DevOps pipeline, but what the business and the developers can do as they're securing their applications and making them as secure as possible, from ISC tests to tests of the container image, all the way into open source libraries, and then SCM integration, IDE integration, CLI. All we're trying to do from a Snyk perspective is make it really easy to integrate into the software development lifecycle, and that's within registries, Kubernetes clusters, SCMs, all those different types of CI/CD tools. What I do want to finally end with is if I had this app in Azure DevOps, so let's show a pipeline, even though I said I wasn't going to, that would look something like this, right? So if I did an edit on that, I've got 2 minutes left, and I'm going to get kicked off soon. I manually install the Snyk CLI using npm. So if npm's on that image that's going to run all the tasks, then you can easily do that. And then I just go run a series of code, open source, container, very simple commands. So just run a container test, get the results, pipe it out to the Snyk to HTML utility, and eventually I'll get something like this. So if I go to pipelines, I click on this, and I click on a successful run, I can go to this HTML viewer, and I get nice little HTML view of the open source ISC container tests. So ultimately, I can still give the business all that visibility in terms of what was tested in a pipeline, but I need to make decisions. What am I going to break and at what time? So that's the end of my demo and presentation.